And then of course, let's say that looking on the ASA, this is the inside interface facing the LAN, and this is the outside interface facing the internet. And you have an ACL configured and applied inbound in this direction, which says permit traffic. That ACL says permit user Christian to any. So you say, let's say you allowed Christian to go out on the internet and reach any destination. Now what happens is when Christian sends an IP packet and reaches the ASA, and that packet has a source of Christian's IP 10.10.33.100 and destination of whatever, XXXX, something from the internet. The ASA needs to know, okay, this IP address belongs to which username, to see on which of my ACL rules do I match with this packet. So what the ASA is going to do, it's two options, it's two ways it can do this. The ASA is going to communicate over via radius with the CDA agent or with the AD agent. So in both cases the same thing. So via radius is going to communicate with the CDA agent or with the AD agent, and via radius accounting messages it is gonna receive that IP to user mapping, also of Christian. Now, technically speaking, how this works is that the agent is going to do a push to the ASA to tell the ASA user to IP mappings. But of course, also the ASA can actually request, can initiate a request to the CDA agent to get those mappings. But then how does the CDA agent know the IP to user mappings? So the ASA knows the user to IP mappings from the CDA agent. It receives them via radius accounting messages. How does the CDA agent know those messages? Because the CDA agent speaks with the domain controller via Windows, via WMI, Windows Message Instrumental Protocol. And the CDA agent reads from the domain controller, those security logs, where the domain controller is keeping all of the successfully logged in users, and in those logs it keeps the user to IP mappings of users that successfully have successfully authenticated in the network. So it's a chain that first, what happens, the user authenticates against the domain controller. The main controller creates a log message, a log entry for IP to user mapping. Then what happens that the CDA agent retrieves that information from the domain controller via WMI protocol, retrieves the IP to user mapping, and then the CDA agent pushes over to the ASA via radius that IP to user mapping. So technically speaking, the ASA just needs to speak or integrate with that agent, not with the domain controller, if you have user rules configured on your firewall. Because the ASA just needs to know what is the IP to user mapping, is going to find that from the agent, and the agent finds that out from the domain controller. But if on your firewall in here you configure the policies not based on users, but you're saying permit traffic to go out on the internet from the group of, let's say, group IT to any, where this IT group is a Active Directory security group. So if this is your configuration on the ASA, you configure rules based on groups, not based on users, so based on group of users. Which technically clearly it makes much more sense, because maybe you would want to say the IT users as a group have this access to the firewall, the legal users have this type of access to the firewall, the financial users have this type of access. So it makes sense to be able to do firewall rules based on group of users, not only based on users. If this is the use case, then the ASA needs to know who is in that group. What are the members of that group from Active Directory? So if this is the use case, if you're configuring firewall policies based on groups, which in general that's what we're gonna do, there's one more additional step that happens, because the ASA needs to know to which group does the user belong to. So with the configuration we've done so far, as this user authenticates, as Christian authenticates, so username is Christian, and IP of Christian is 10.10.33.100. We know what happens. The user authenticates to Active Directory. The domain controller creates a log message with IP to user mapping. The domain controller sends those IP to user mappings to the CDA agent, and the CDA agent sends the IP to user mappings to the ASA. But the ASA does not have rules configured based on users, but based on groups. So when the ASA receives that packet, when the ASA receives a packet from Christian going out on the internet, and the ASA has this rule configured, which says permit, let's say, let's use green. The ASA rule says the following: permit the group of IT, or let's say that Christian is a member of group of IT, out to any. The ASA is, at this point, is not enough to know the IP to user mapping in there. The ASA has to know if Christian belongs to this group. So what this means is that with this type of configuration, the ASA also needs to integrate with the domain controller. So the ASA is able to query the domain controller to which group does Christian belong, pretty much. It's not going to query the domain controller, it's going to actually read the schema and find out by itself what are the members of this group, to see if Christian is a member of that group, to see if it allows traffic from that IP address. Because now this is the, let's say, the challenge now on the ASA. We have a double challenge, not only the IP to user mapping, but also group to user mapping. Because now first, when Christian sends a packet out on the internet, when Christian sends a packet to the ASA or a source of 10.10.33.100, destination of whatever, XXXX, the ASA has the IP to user mappings, and it knows that this IP of 10.10.10.33, it belongs to user Christian. It received that from the CDA agent via radius. But then if I want the ASA to allow that traffic to flow through, and let's say I have only that rule configured, the ASA needs to know, does this Christian username belong to this group of IT? And the only way that ASA can identify that out is not via radius and counting messages. The ASA has to identify by looking in the Active Directory schema and seeing if username of Christian belongs to the group of IT or to whatever other group it belongs to. So that's why configuration wise, in general, because you're going to in general configure rules based on groups. So configuration wise, you're gonna configure on the ASA, you're gonna configure integration with Active Directory via LDAP, because the ASA has to be able to identify the user to group mappings from Active Directory. And when you do this integration, you're gonna configure a username on the ASA, and that username, those credentials need the rights to read the AD domain or forest schema. Ideally, Cisco recommends that the username that the ASA uses for an LDAP query to identify the user to group mappings, Cisco recommends that user being used is a member of the domain admins. It doesn't necessarily have to be a member of the domain admins, as long as the reader had that username which the ASA uses, that AD user, that the user from Active Directory, which the ASA uses for LDAP queries to identify the user to group mappings. As long as that username, those credentials, can have the rights to read the AD domain or forest schema, the LDAP schema, is good enough. It doesn't have to be a member of the domain admins group. Then we have to configure the integration with the AD agent or CDA via Radius. We know this is required for the ASA to retrieve the user to IP mappings. This is just a regular Radius integration via a pre-share key. So no credentials, special credentials required in there. We have to configure identifier specific options, and then we have to configure identifier policies, which means ACLs based on users or groups instead of IPs as the source address. So again, I gotta make sure everybody understood this clearly, that you're gonna replace in an ACL the source IP address with a username or a group. Destination IP address remains a destination IP. You cannot also replace the destination with a group in there or a user. Now on the AD agent or CDA configuration part, depending on which version you use, the old AD agent, or the new CDA agent, you of course first have to install the AD agent or the CDA agent. Then you have to configure the integration with the ASA Firewall via Radius, so that the CDA agent or the AD agent pushes over to the ASA the IP to user mappings. You have to configure the integration with Active Directory via WMI, so that the AD or CDA agent retrieves the IP to user mappings from the domain controllers. And when you do this integration, likewise, the username used to read those logs, the security logs from the domain controller, needs right to read those logs only via WMI. Cisco recommends, of course, also this user to be a member of the domain admins user. It doesn't have to be, but of course, if you use a domain admin, it is going to work. An option, you can configure syslog servers. So like whatever is, let's say, wrong on the AD agent or CDA agent is going to be also sent out to a syslog server. So looking back in here, it is very simple. The ASA speaks Radius with the agent to retrieve the IP to user mappings. So for IP to user mappings, the agent speaks WMI with the domain controller, likewise for IP to user mappings. And then finally, the ASA speaks LDAP with the domain controller. So ASA speaks LDAP with the domain controller, LDAP. And this is to retrieve the IP to group mappings. And then on the ASA, as we saw, you configure ACL rules with usernames as instead of the source IP addresses, or groups instead of source IP addresses. Verification wise, you verify the integration with the agent, show user of identity AD agent. It's also going to show you if the configuration, if the integration with the A server is up. And we can also say test a server AD agent to also test the integration with the AD agent, because this is nothing else but a Radius integration. You can verify the AD users in groups, which means you verify if the ASA can properly query the domain control, like the LDAP integration has been properly done, the credentials are valid, the configuration is valid, and if the ASA knows, like show user identity AD users can read the users from the domain, from the Active Directory domain, or show users AD groups, which means ASA can read the security groups from the Active Directory domain. So that's all to verify pretty much the integration with both the agent and the AD. Then you verify which users have active or inactive connections through the firewall, of course assuming you have configured rules with usernames or groups, with the command show user identity user all list. You're gonna see which users still have now active connections to the ASA and which users had connections to the ASA that's going to be inactive users. Or can of course verify what is the IP address of a specific user, like you can verify the IP to user mappings with the command show user identity IP of user and then followed by domain/username. So you're going to say show me the user of identity, what is the IP of user, and then you say the domain name like inlab.local/username like Christian. If you look in those two documents in here, one of them also shows you the configuration part of using the old AD agent. So this is a document from Cisco support community. If you look it up, is called Identity Firewall Step-by-Step Configuration. I haven't found a configuration one for the one with a CDA. This is with the old agent. But the only difference between it doesn't matter if you use the old agent, the AD agent, or the CDA agent, the new agent, or in the ASA, the configuration part is the same. On the agent side, the configuration part is the same, but because it's two agents, it's going to be done differently via the CLI only with the old agent and with different commands, or via the GUI or CLI for the new agent, where the GUI is like ICE and the CLI is pretty much like a regular iOS router, for example. The steps are the same, features are the same. As we saw, the difference is that the new agent supports to grab the IP to user mappings also from ACS or ICE. So you can look at this document to have a better idea of, for example, let's look at the configuration part. I'm not sure if they show the ACL rules on the ASA. They have one rule in here which states access list inside ACL extended permit IP user and its domain name/username as the source. So the source becomes user domain/username, and destination is still like host 10.10.10.1. So with this feature, we replace the source IP from an ACL with the username or the group. The second entry is for a group in here. So the second entry is for a group, not for a user, where the source is, as you can see, user group, and then domain name DC1 /specialists. So that's how you configure in the ACL a group. You say user group, not user, and then you put in there the domain name / and then the group name. Of course, and the destination remains the same, configured as an IP Destination is host 2020. The third option in here is still, we're not sure exactly if it's based on users or groups, because the third options makes use of the object group of type user as the source. An object group named users. So we have to look in that object group named users to see if in there they reference a user or also a group of users. So in that object group, which is configured in here, the container is this one. So we have the object group of type users configured, name users. And in this object group, we say that a member of that object group is only user named user1, which is a member of the DC1 domain. And only if that user, so this is the username. So we have only one username as a member of that object group. And that username is a member of the group called specialists. So in that object group, we have only one username named user1, which is a member of the group name specialists. So pretty much it means that the third rule is a more, it's not a type of rule where it's not based on user, it's not based on group, it's based on a pair of username group. Username group. So it's a more strict configuration, the third ACL entry, which says I'm gonna allow traffic from that user, but only if it's a group of, it's a member of that specific group in there.